All right, I want to go through the note, finding the equation of a line from data, which means we have information. All right, so by examining a table of values for a linear relation, which means it has to produce a straight line when it's graphed, an equation for the line can be found. All right, so the first few things that we need to know is what a y-intercept is, and hopefully by now you do. But just to clarify, because it's also known as b in the equation, again, I'm not sure why they picked that letter, but the y-intercept is the point where the line hits the y-axis. And so the x-intercept is essentially the same thing, only it is the point where the line hits the x-axis. All right. Now, how do we find those things? Well, I've got a couple of graphs here. Examine the following graphs and determine the y-intercept and the x-intercept. So I'm going to do the x-intercept first. All right, and so on my line here, I look, there's my x-axis, and I move over and I look to where the line hits it. There it is. -4 is our x-intercept. I can do the same thing in B. Again, if I follow along my x-axis, and there it is. There's where the line hits. The number is 5, so the x-intercept is 5. And now the y-intercept. So again, that is where your line hits the y-axis. All right, so I'm going to pick a different color here. Let's go with red. Now this is the one we're the most interested in because that is part of the linear equation, is you have to know the b value or the y-intercept. And so again, I follow my y-axis. I go up and there it hits. And the y-intercept is 2 for that graph. I do the same thing here over in B. I go down the y-axis and I see where my line hits. And that point there is -3. That's where the y-intercept is. Now, the location of it. What I mean by the location is its x and y coordinates. And for our first one here in A, the y-intercept is 2. But to get to that coordinate, I wouldn't go left or right at all and then just up 2. So that means the point is at 0 and 2. All right, the same thing for B. If I look at the y-intercept, there it is. Again, if I want the xy coordinates, I don't go left or right at all, but I do go down 3, which means the xy coordinates would be at 0, -3, which then helps us answer the next question. At the y-intercept, the x coordinate is, well, look at it here. It's 0 here and it's 0 here. So guess what? The x coordinate, it is always 0. All right, so that's going to be a key thing that we're going to use. All right, now to find the equation of data. All right, so I have a linear relation has the following points, and what I'm going to do is put those in a table of values. All right, so my first point is -5, 6. So I got -5 and -6, I should say. There we go. Our next point. Let's see where we go. We have 0, -4. So there's 0. And our y value is -4. All right. Next up, we have 5 and -2. All right. So I'm just placing these points here into my table of values. And you're going to see why here shortly why I'm doing that. So I got the next point is 10 and 0. And then finally we have 15 and 2. All right, so now here's what we're going to do. We are going to find what's called your delta x's, which I'll put over here. Let's see. Oh, I don't have a delta x. So I'm going to have to draw that. So let's see here. There's my delta x's. And so what I'm doing with my delta x's, delta is science and math means change. And so I'm looking for the change in x. So I look at these two values here. From -5 to 0, what has happened? Well, we have gone up 5. I do the same thing again for my next two. From 0 to 5, what is happening? Well, again, I'm going up 5. All right, and the pattern does keep repeating. So from 5 to 10 and then 10 to 15, From 5 to 10, it's going up 5. And of course, from 10 to 15, it's also going up 5. All right, now I'm going to do the same thing on the other side, but because I'm looking at my y values, I'm going to find what's called my delta y. All right, and again, I'm looking at what is happening. How's it changing? Well, if I go from -6 to -4, -6 is very negative. -4 is also negative, but it's less negative. In fact, between, whoops, I should draw a line here. Between these two, I am going up 2. From -4 to -2, I am also again going plus up 2. From -2 to 0, again, I'm going up 2. And finally, from 0 to 2, I am again going up 2. All right, well, how does that help us? Because the slope, which again is called our m value that we plug into our linear equation, can be found using the following formula. Delta y divided by delta x, which means in this case, our delta y was 2, and we are going to divide that by our delta x, which I look up here, is 5. So our slope is 2 over 5. So I'm going to put that in here. So there's our 2 divided by 5. The y-intercept. See the note at the bottom of the last page that we did. Okay, so how am I going to find the y-intercept? Let's look back at the first page. At the bottom it says, so we look at the y-intercept. The x-coordinate is always 0. Okay, so now I go back. Where is the y, the x0? So I'm going to use a different color here. Let's try red. Well, here is the x is 0, and guess what? That means there is our y-intercept. Our y-intercept is -4. So I'll put that in there. And again, that's just by finding out where the x is 0 and moving over and seeing that's the y value is -4. All right, so then we can write down the equation of a line, because again, you only need 2 things to write the equation of a line, because the equation of a line is in the slope or in the form y equals mx plus b, where again b is our slope, b is our y-intercept, m is our slope. And so if I plug my values in here for the equation, I get y equals 2 divided by 5, because that's my slope, times x. And what's my y-intercept? -4, so I get a -4. And there's the equation of our line. In the next video, I will do the 3 examples.